So today we're going to look at how to calculate the linear regression, and I hope you've already watched the video on how to calculate the Pearson correlation before watching the linear regression, because they're somewhat interrelated, and you also be learning some a little bit of how to calculate the measure of central tendency, particularly the mean, to understand how to calculate linear regression. So let's get on with it. So what I've done here is that I've only presented you with all the equations, and I'll give you a sample and also the solution to the sample. So everything is on display. I'm only going to take you step by step how we arrive at the answer and what is regression, starting from the slide. So as you can see, regression line is y equals to a plus bx. That is the formula to calculate the regression line. So what is y? Y is actually known as the dependent variable, and a is known as the y-intercept, while b is known as the slope of the regression line, and x is the value of the independent variable. Now, why do we do regression, and what is so significant about regression as a whole? Now, when you do correlation, correlation simply tells you the relationship between two variables, that is between the dependent and the independent variable y and x. It only tells you if the relationship is positive or negative. We did that in Pearson correlation, or we also did the Spearman correlation. It only shows you the direction, the relationship, the strength of the relationship. That is what correlation does. But regression takes it a step further by explaining to you the prediction. It allows you to understand what will happen if you know already the relationship between y and x. How can you predict y, that is the dependent variable, if you are given x? So regression is more intricate in the sense that it allows you to predict the result of the equation of the relationship between two variables. Now this is very significant because your final answer is always going to be written in a regression line format. This is significant. The first answer you get must be written in a regression line before you can predict. So in order to calculate this regression line, you can see y and x are what are the variables that you have, but a, that is the intercept, and b, the slope, is what you need to solve. Now to solve for b, this formula looks a bit familiar. If you recall, in your correlation, Pearson correlation to be specific, the numerator is identical with Pearson correlation. So it's kind of save you time if you're trying to memorize all the formula, because you already have it in the Pearson correlation. The only difference with this b intercept, that is the slope of the regression line, is that there is no square root and there is no information for the y, that is the dependent variable, the equation for the y variable. So you only have this top numerator, which is similar with the Pearson correlation, and the denominator, which is similar with the Pearson correlation without the square root and the y equation. Now, if you look at the intercept, you have what you call the y bar minus the bx bar. This implies that in order to calculate the regression line, you must first find the b. You must find the slope of the regression line. So, and then you need to calculate the y bar. The y bar simply means the mean of y. Summation y divided by n will give you y bar, and x bar, which we should be familiar with, is the mean of x. The summation of x, addition of all the variables of x divided by n, the total number of the variables in x. So moving on, I hope you can write this down, because when we move on, I will continue to use the word y-intercept to represent A and slope of the regression line to represent B. So we're going to look at an example, a quick example. Like I said, I already did the example, but just to take you through the step. So a school coach is interested in predicting a student's 1,500-meter race finish time based on the number of laps they run weekly during training. The coach collects data from 5 track team members. So here are the team members. You have Shepo, Tendai, Nicole, Pascal, and Reindeer. And these are the laps that they ran. And it's supposed to be 1,500 meter time. I forgot to edit this part, apologies. So what we're trying to do here is that we want to see the relationship between their average time, the laps per week, and the number of time minutes that it takes them to complete. That is when they train, and the amount of average minutes that they clock. And we are also going to ask a simple question. Using the simple linear regression analysis, determine the equation of the regression line and predict the 1,500 meter time for Anthony, that's me, who trains for 22 laps per week. Okay, kindly ignore this error here. It's supposed to be 1,500 meters. But let's look at the solution. Let's see how do we go about it. So here are the team members again. Here are the values for X and Y, which didn't change. But as you can see, we have done the summation of X. That is, add all the X values together, sum up all the Y values together. But we need to create a new column for XY. That is, each of the X multiplied by Y. 10 multiplied by 7.5 is 75. 15 multiplied by 7.0 is 105. We do the same all the way, and you get all these values. Now when you sum them up, you get 518.2, summation of xy. And we also have to do the same column, create a new column for x squared as well. That is, each of these x value, we square them. 15 squared is 225, 20 is 400, 12 is 144. You square them, and after squaring them, you need to sum them up again, and summation x squared is 1,193. Now take note of all this information because I won't be repeating them in the next slide. Now, remember, if you recall, I said you need to calculate the slope of the regression line, that is the B, before you calculate the y-intercept, which is the A. So it's B before A, right? Now, to calculate B, our number, our n is 5 because the total number of values we have for each x and y is 5, multiplied by summation xy, which is 518.2, minus summation x, addition of all the x value, which is 75, addition of all the y value, which is 35, summation y, divided by n, summation x square, which is 1,193, is different from this, minus 75. This is x, and then we have to square it. So summation x, that is 75, we square it. Now if you do this on your calculator, you should get negative 34 divided by 340, which will give you 0.1. Now, if that is fine, you can turn your attention. So we are done with calculating B. So this is the value of our B. Now we can calculate the Y, a Y bar and X bar, so that we can calculate the y-intercept, that is for A. So for Y bar, remember I said the summation Y divided by N. So since our summation Y is 35, as you can recall, divided by 5, which is our N, it will be 7. We do the same for X. X bar means addition of all the X value, that is 75 divided by 5, which is equal to 15. Now, see what we did there. To calculate A, which is the y-intercept, we simply plug in the y bar, 7, minus, that is part of the formula, right? Negative 0.1, which is our B, the slope of the regression line. I put it in a bracket because it's a negative. But if it was a positive, I don't know, I could just put the number there. But because it's a negative, I need to be very careful, and that's why I placed it in a bracket. Multiplied by 15, which is our x bar, our mean. This is in the formula. Now, you have to be careful here because we are dealing with the negative sign. 15 multiplied by negative 0.1 will give you 1.5. But 1.5 multiplied by negative sign before when you open up the bracket, it will turn into a positive. That is negative multiplied by negative become positive. So you have two negative signs beside before the bracket. Is definitely going to turn to a positive. Minus times minus. And positive 0.1 times 15 will give you positive 1.5. So 1.5 plus 7 is 8.5. It means our A is 8.5. Now, I said you need to first get the regression line before you can predict. Now, this is our regression line. Y is equal to 8.5, the A, minus our B is negative 0.1. Don't forget that. It is not positive. Negative 0.1 x. All right, but remember it's y equals to a plus bx. But because our b in this case is a negative sign, it affects the sign, and that is why it is 0.1. If it was a positive, it will remain 8.5 plus 0.1x, which is 5. Now the follow, so we leave the answer like that. So you probably get a marks for writing the regression line, because if you don't get the regression line, you can't predict. Now remember, the question says predicting the 1,500 meter time for Anthony, who trains 22 laps per week. So if Anthony trains for 22 laps per week, what is his average time then? So it will be 8.5, right? Y is equal to 8.5 minus 0.1, which we still have here. Then you just plug in x is equal to 22 in the bracket. So 22 multiplied by 0.1, and you deduct it from 8.5, you're going to get 6.3. I believe that is how you solve the regression. And if you have any question, you can always drop it on the comment section. Thank you.